Hello everyone, welcome to Inside Science and Technology channel. In this video, we are going to learn about SVM, which is fully known as Sport Vector Machine. We are going to look into the working principle of SVM. So, starting with the video, what is machine learning? The question arises that how machine learning learns or how it can play any role in daily life of human. So machine learning basically mimics learning by training a computer how to learn and improve from experience without being programmed by humans. So it's a self-learning mechanism. It's not dependent on the humans, but obviously the designing of machine learning is dependent on humans, but the learning mechanism of machine learning is not dependent on humans. One of the tasks in machine learning is to classify a set of objects or data into two or more categories. By categories we mean classes. Now it can be two classes or it can be more than two classes. Obviously whenever we are talking about categorization or classification, we cannot say that it will be having single class. For classification purpose, we need at least two classes or more than two classes will be part of machine learning algorithm. So classification is used to categorize a data set into classes. Its purpose is to recognize data from dataset and separate the data into classes. A classification algorithm will be used to categorize vast amount of data from the dataset. Like for example, here we can see that there are some images being attained from different walls, from different marbles, from different agricultural land, different crops, and different stones. So if we need to categorize those images, right, we need to have the features that are capable to make the learning of any classifier being possible. So SVM can be used to classify the data into different categories. It can be greater than two and it can be as many as we want SVM to get trained on. But we need to take this thing into account that whenever we are talking about more than two classes, obviously we need to give the different features. Those are capable of being discriminative within different classes. So we need to take care about that as well. So talking about SVM classifier, so SVM is one of the most simple and effective method for classification. SVM is an algorithm basically which have high accuracy and it consumes less computation power. Computation power is again one of the major concerns when it comes to machine learning algorithms. So SVM can be used for both regression as well as for classification purpose. But in this video, we are going to see SVM as a classifier. And in some of the upcoming videos, you will be learning about SVM being treated as a regression model. So the better will be the training of SVM, the more accurate will be the SVM. Now, talking about the machine learning approaches, so there are two major machine learning approaches, which are supervised and unsupervised learning algorithms. All right. In supervised learning, we teach the machine learning model by exposing the model to the features by ourselves, and the features will be labeled. Now, what that means is we are going to tell the model that this particular feature belongs to this particular class, and these particular features belong to that particular class. So we are going to teach the model by exposing whole detail about the features and its labels. So what does that teaching means? Teaching the model, teaching the machine learning algorithm, what does that mean? That means that we train a model by data from a labeled data set. Means the data contained in the data set is labeled or classified correctly. Now, what does those features means? By features, we mean taking an example of a triangle. So how we visually classify that this particular diagram is a triangle? Because we know that the triangle have a shape with three sides. All right. So in that particular case, we know about the features of the triangle. In similar way, we are going to train the model with such features which by learning which it will be capable of classifying the features, and ultimately we will be able to classify the data set. Now, we do this because we want our model to take in new input data and independently predict its correct label. Now, talking about unsupervised learning, so SVM is completely a supervised learning algorithm. But talking about any of the unsupervised learning model, so we give features to the unsupervised learning machine learning model, and we ask the machine learning algorithm to learn itself and to discriminate the features itself without knowing about the labels. So that is unsupervised learning. Now, talking about the training of the SVM model. So a labeled data set is used for a training model, as being previously discussed that we need for supervised learning we need a labeled data set to train SVM. And SVM is a supervised learning algorithm. So SVM is said to be a supervised learning algorithm because SVM requires a labeled dataset to train a model. For example, using SVM, we can predict the cancer cells images, and further we can predict where either the cancer is available or the cancer is not available. By training our model using large number of labeled cancer cell images, we can effectively make a machine learning algorithm for the division of cancerous and non-cancerous cells. By non-cancerous cells, I mean normal cells. So, moving further, how does SVM works? What is the working principle of SVM? Every object we want to classify in is represented by a point in an n-dimensional space, where we can say that n refers to the number of features. Now those features are dependent on us. Better will be the features, better will be the learning of SVM, better will be the accuracy given by us to the SVM, given to us by SVM. So if there are two features, then 2D space will be enough to categorize the classes. Now here we can see that we have an example of two features, where feature 1 is color and feature 1 is of weight and feature 2 is of color. Now what is the object? Object is cat. We need to categorize that either the image contains a cat or a dog, right? So that can be done using color and weight. Now weight is a feature which is obviously difficult to be learned by the classifier, but then again, with a huge amount of data, we can say that through the density being covered by the object in the image, we can say that we will be able to categorize cat and dog based on the weight feature. So now what we need over here, what SVM performs. So we want to find a line which will separate the data of two categories, and the line is far away from points of either of the category. Now what this line actually means, what this line is known in SVM mechanism. So talking about SVM working, I will be telling you what that line exactly means over here is. So now for suppose we have these feature points being available to us. Let's say this belongs to cat, all right, and there are some other features being made available to us. These features belong to dog, all right. So we want to categorize them, all right. So what that line meant was hyperplane. There is a hyperplane between the feature points of two classes to categorize them into different classes. Now moving further, so classification by SVM is achieved by drawing a hyperplane, which is a line in 2D plane. A hyperplane is a line drawn in such a way that all points of category 1 are on one side and of category 2 are on the other side of the hyperplane. A hyperplane is a line if number of features are of 2D space. If number of features are 2, it would be 2D space. If there would be 3, that would be 3D space. So the space increases with the increase of features, and it is termed as right now we can say that this particular hyperplane is a two-dimensional plane which is able to categorize the features. So now moving further, taking another example, or taking a deep look of SVM mechanism. So what does it do? We have class 1 over here, we have class 2 over here. Now it is going to draw the hyperplane. Now this particular thing, this particular line is a hyperplane, all right? And alongside of hyperplane we have a margin. Now this is always being drawn, and this is being drawn on the base of the point, the feature point, which is nearest to the hyperplane. All right. Now over here, similarly, we have this margin being drawn at this side. All right. So what these particular feature point are known as? This point and this point are known as spotting vector. Now, talking in depth about it, so a multiple number of hyperplanes can exist, but the job of SVM is to find a hyperplane, a line which separates the two categories of objects in the best way possible. SVM achieves this by extending the distance from the hyperplane to points in both the categories, or you can say classes. This extended distance is called margin. Now, this margin on both of the side, it can be different. Like I can say this, if this distance is d1, so this distance can be d2. So d1, it is not important that d1 is equals to d2. We don't want this to be equal because it is totally dependent on this spotting vector. So we want to find a hyperplane which has the max margin, means a hyperplane which has the maximum distance between both of two categories. Maximum distance is used to ensure that the classification of any future data is optimum, mean there is a clear distinction between two categories. That means that there should be intra-class variation in the features, in the feature points. That's what we mean from here. Now, moving further, so another example, we have class 2, we have class 1, a hyperplane is being drawn between them, but there is a problem. What the problem is? The problem is this particular feature point. Now we cannot draw any particular line over here for just this feature point, so that we can classify it in a better manner. So this one is known as outlier. All right. Now that will be obviously false prediction by the SVM, but we need to keep this thing in mind that SVM has a feature to leave out the outliers, a point existing in other class far away from its own category. But in future, we are going to learn about those classifiers as well. With the advancement of AI, artificial intelligence, we have some classifiers which are capable of reducing the outliers. Over here, we are just having one example as an outlier, but in actual, we can have more outliers as well, like this one, like this one. We can have many more outliers being available. What if we have these features over here, these particular feature points over here, and we have this over here as well, and this particular belongs to class 2. Now what we are going to do, we are unable to classify it. We are unable to make such a hyperplane which is capable of discriminating all those feature points. So ultimately, the best classifier or the best feature vector and the combination of it with the classifier is when we are able to reduce down the outliers. Now that's what we are looking forward. Obviously, we are going to look into those classifiers as well, or those advanced artificial intelligent networks as well, which are capable of removing or reducing down these outliers. Now, that was all linear data. We used to make a straight hyperplane that can be in two-dimensional, that can be in three-dimensional. With the increase in features, we can go with the more dimensional hyperplane. But we have an example where we have a non-linear data. Non-linear data, we mean such a data which looks like this. Now, there's a problem. We cannot make a single hyperplane over here. If we make this particular hyperplane over here, we will only be able to classify two data points. Means from a data set, only two images or two samples would be able to classify correctly, and all of these will be incorrectly classified. Another thing can be if we make hyperplane. Now there are different ways of making the hyperplane. We make this hyperplane, obviously four of the class 2 samples would be able to classify it betterly, and other will not be classified in the same manner. So now this particular problem can be solved by SVM itself. Before going into how to solve this problem, just a summary that what was going on with the data set such like this. Obviously, we can create a hyperplane over here which can classify class 1 and class 2, right? Now, what that hyperplane will be, here we go. We have a hyperplane. We have a very good classification algorithm being designed, being trained. So we can classify class 1 and class 2 very effectively in this particular problem, because this is a linear problem. But coming back to the example, we were having a problem with non-linear data. Now, non-linear data can be categorized by SVM. How? Why not to make a circular hyperplane? We can make a circular hyperplane using SVM, and that's one of the capability of SVM, and that is why this is one of the most used classifier in the field of machine learning. So I think that is all with this particular video. We are going to look into different classification algorithms as well. We are going to look into different implementations of SVM in MATLAB as well as in Python as well, so that whenever you guys are trying to implement it in real world, you guys will be able to have hands-on experience with its implementation. That is all with this video. I hope you like the video. Hit the like button, subscribe the channel, and hit the bell icon as well. Thank you so much for watching the video.